Hi Smarters, welcome back. So now we're going to talk about resistance. So a resistor resists the flow of current through an electric circuit. So we're going to use Ohm's law, which is V equal to IR, but we say that the resistance is equal to the voltage divided by the current. So now we're going to check resistance in series and also parallel, but we should remember that this is measured in ohms. Yes. So so this is our series circuit. This is R1 and this is R2. So the thing that is happening in a series circuit, the total resistance is the sum of the resistance. So R in series must be equal to R1 plus R2. But then in the parallel circuit, let me quickly draw. There's this one here, we have R1 here. We have R2, and we say that a parallel circuit, we see it because when current is flowing through here, it's going to split. Another is going to go to this direction, another will go down, but then at the end they will come together, right? So we're saying that we're going to take the inverse. So 1 over R in parallel must be equals to 1 over R1, right? Plus a 1 over my R2, right? So in another form, we might have the resistance in this form where we have two resistance R1 and R2 connected in series, but they are all in all parallel series, parallel circuit. This is my R3. So what is happening here is that from here the current is the same, and then it splits. Another goes to this direction, another goes to this direction. But what we need to observe here is that the current that is going in this direction, it's going to be the same for this and this, meaning that they are in series. So we're going to say 1 over Rp must be equal to 1 over, and then we say that this one, they are both in series, and when they are in series we add the current. So we're going to say R1 plus R2, and then we say plus 1 over R3. So what we need to do at the end is to take the inverse of this, saying that Rp, therefore Rp must be equal to R1 plus R2 plus R3, and then we do the inverse, right, for each and every one of them. So you need to remember that when you get into a parallel circuit, when you see a parallel circuit, you need to first check if there's nothing connected in series or anything, just like that. And then now we need to move on to potential difference. So potential difference, we're talking about the voltage, right? And what is a voltage? A voltage is the work done per unit positive charge to move a charge from one point to another point. So here we'll be dealing with EMF, right? What is EMF? These are some notes that you need to know. EMF is the same as voltage. Is equal to voltage. It's the voltage across the cells where there is no electricity flowing or where there is no current flowing. So this, you get an EMF in an open circuit, right? So voltage across cells when no current or charge is flowing, right? So we're saying that EMF is in an open circuit where the voltage across the cells have no current flowing. within them. So we also have V term or VT, which is the total voltage when there is current. So we say that this is the voltage across cells when current is flowing, right? So now we're going to look at few examples on how to solve for the voltage potential difference in a series. So in a series we have our resistors R1 and also my R2. Then we have, sorry I didn't draw it well, but you'll forgive me for this one here. This is my V1, this is my V2. So voltage in series is equals to V1 plus V2. The voltage is not the same, right? And then we say that we have a parallel series. So in a parallel, we know that we have R1 with its own voltage, voltmeter, right? And then we have R2 with its own voltmeter, and then this is V1, this is V2, and then this is V3. So this voltage is in parallel. So parallel voltage, we say that the V in parallel must be equal to V1, which is the same as V2, which is the same as V3. So let's say that, you'll forgive me. So this is also for parallel. It's coming this side because there's no space here anymore.